Hello everyone, today we will talk about polynomial regression. So in the previous slides or the previous videos we learned about linear regression. So assume that we have this data x and y, and we try to draw a line to split this data or to fit our data. So the best fit, let's say the best fit is this one, and if you compute the error area, we have some error. For example, from the distance from this point to this line, and also for other points. So the cost will be somehow high because the data is somehow spread about it's not close to the line. So what about if we have data? For example, the previous slides, we have a good data, and we can at least split or draw a line. But here, if we split this line, it just go through this line, this points. What about this part, and also this part, and also this part? And if we do it again, just to split this and this, it just go through. It goes through some points, and all of these are far away from the line. So the polynomial regression, it comes to overfit or to solve this problem. The polynomial, it means I will draw a line, fit your data with some polynomial degrees. As you can see here, this is a not linear line, straight line, it's a curve. So the polynomial features, how to add your in. Before adding some features or polynomial, if your model is not working good, or the accuracy or the error is high, so you should think about polynomial. The polynomial, it means I will add some other features in your training set. For instance, assume that we have, as we said, x1. This is the first part, and we add x squared to the power 2. Now, this, for example, this function polynomial features, it generated the additional parameters. So assume that we have two features, a and b, and apply polynomial features with degree 3. We will have these features. So instead of only just use part of the data, we will use all of these features, and it's about 10, I think, with degree 3. Now here's one example. For example, if we try, this is with degree 1, it means linear regression. With degree 2, we add the degree 2 to our features. This will split the data like this. If we add 300 degrees, it will be very huge number of features, and this the fit of our data. But where should I stop the polynomial? So here's the example. For instance, the disadvantage of high polynomial, it's overfitting. And the disadvantage of low polynomial, it's underfitting. To understand this concept, we should draw this slide. So overfitting and underfitting, of course, I think you already heard about this stuff if you learn machine learning. So assume this, we have this data set, and here's the linear line, and here's the polynomial with degree 2, and let's see here with polynomial degree 4. As you see here, degree 4, it's the best fit to our data, but there's some disadvantage in this polynomial and also in this one. What's that? As you see here, the number, the error, it's almost 0, because if you compute the error from, if you compute the distance from this point to this line, it will almost, let's say almost 0, because it's just drawing by hand. And if you compute the cost from all of these points to the line, you will have high cost. This means in this case, bias, the bias, it's very low. Bias, it means it's used for the training. So the model, the data is biased from the training, it's zero, because as you said, you compute the cost. And also here the bias is high, and is in this polynomial with degree 2, it's somehow better than this one. It's between this and this. So again, if you see this, the linear, we will compute the distance from all of these points to the line and sum it up, or take the average, and also this one and this. And in this case, we will have high cost or high error, right? This called underfitting. Let's go to this one. Yeah. Now, regarding the training, it's high bias because the cost is high. If you go to the overfitting, what does that mean? What does overfitting means? Overfitting mean I can work on the training without any error, or with small range of error, let's say close to zero, but I cannot work with any data, testing data. Assume that, for example, we have point C, so it will the error will be high. We will see it in the next slides. Now, in this case, if the error is high, it means our model is underfitting. If the cost is low, our model is overfitting. So and now we have, for example, regarding the testing. If we add, I mean, this is the training. If we add now these 6 points as a test data, as a testing, we will have some errors, right? So the distance from here and here, it will high bias for the training, high bias, and for the animation it's not good, and high variance for the testing. It means I will have large or much error regarding the testing data because it's far away from this line. In the opposite direction, or the opposite linear polynomial degree, this one. In the training, the accuracy or the cost is zero. But if I have new data, I will have high variance. So this is the underfitting and overfitting. To control to handle the underfitting, you should add some other features. Let's see, in this tutorial, you should add some polynomial. For example, polynomial 2, 3, and it's not there's no, for example, rule to stop or stop your polynomial. It's based on your data. Now, to handle overfitting, we have to remove some polynomial. For example, here it's 4. Just don't use 4. Use, for example, 3. Right? And this is the basic idea of underfitting and overfitting. Low bias, bias on variance. Thanks for your watching. See you again.